All right, so we're going to be going through how to do some more interesting things in a VI today. I think last week we looked at, memory serves, just basics of LabVIEW. We played around a bit with building a VI, doing some math in it. This time we're going to be doing something a little bit more interesting. I'm going to make a VI to gather data, plot it, and then also save it to a file. Another thing that's of interest to us is changing how quickly we acquire data. For example, if I'm trying to monitor, say, the depth of a stream, that's not something that's going to probably change on a millisecond to millisecond basis, even though that's how fast LabVIEW runs, right? So every time I go through a loop, it only takes maybe a millisecond or less of real time to pass, right? So instead, we want to be able to control how quickly we process data, or how quickly we gather data. So all those are going to be items that we do. So let's get the show on the road. So I'm going to just throw down a dial. Throw down. Let's see. Want a stop button would be nice. Oh, I'm not in the express one. Stop button would be nice. But stop button. Put a rocker switch in, and let's grab an XY graph as well. All right. If I want to be fancy, I could do some other stuff, like put like a recessed box around things and make it look snazzy and send that to the back and whatever. Well, I used to be able to send that to the back. There it goes. Send that to the back and make it look snazzy and whatever. Anyhow, so I have all my stuff here. Couple things. One, I want to change the dial so it goes from 0 to 100. So I'm just going to click on my highest one, change that to 100. I'm also going to make the dial a bit bigger. Move that switch around. That guy over here. An organized front panel is a happy front panel. Again, I don't see a need to have that on the stop button, so I'm just going to get rid of that. My switch here, this is going to be what I use to save data. So I'm going to rename that appropriately. Try to center it a little bit there. Maybe that works. I need to arrange that a little. There we go. Make that bold too. That bold. Great. Those aligned. This is my input value. Instead of a sensor, I'm going to get data from my dial. There we go. I'm going to graph it on this XY graph. Call this my output data. Cool. I'm going to want to have this in seconds. That's my goal. And then the amplitude will just be whatever my dial value is. All right, so there's that. If I jump over to my block diagram, I see a whole bunch of stuff here. So let's just arrange this a little bit. Not going to worry about the save to disk button for right now. I'm just going to throw that off to the side. But I'm going to want to run all this. So let's get this show on the road. So before, I'm going to want to throw everything into a while loop so it keeps on running. Wire up my stop button. Great. All right. So what I'm going to want to do is I'm going to want to set up my XY graph so that it's continuously plotting stuff for me. So let's get that set up. The trick is if I just take a wire from my input value from my dial, that's just one value, right? I'm going to have to build an array here to store data values of the dial for me. It's kind of like in Python. We had to make a list, and every time we we started with an empty list, like an open bracket, a closed bracket. And then every time that we went through the loop, we'd add a value to that list, right? We start with an empty list, open bracket, closed bracket. We just keep on adding to that, right? So we need to start an array of some sort and keep on adding stuff to that array so we can plot it all. All right. So if I go into my programming palette, got a sub palette called array, so I can pull that up. One of those blocks is a build array block. I'm going to drag that in here. It's a single block, so I can put something into this, say my input value, and it becomes an array. At least that's what the label says. But I just won't want to put a thing in and have it become an array. I want to like take my old array and add more things to it, right? That's what I want to do. So I'm going to get rid of that wire. I'll go over and hover over this block for a second. You see those two blue dots there, top and bottom? Click one, I'm going to drag it out. Now I can take two things and merge them together into an array. Well, I know what one of those two things is. It's my new value. The other one I want to be whatever comes out of this. But how do I feed it back into itself between iterations of the loop? That really is the question here. So in LabVIEW, we do that with something called a shift register. So if I go over to the border of my while loop and I right click and go down and hit add shift register, and see what comes up on each side. If I wire the output of this build array to the right hand side, I take whatever array comes out of this block, take it to the end of the while loop. The shift register moves, carries it over to the next iteration, and I can feed that back into my build array block. So this wire here carries the array. This wire here carries a number. They're shoved together in this build array block. The resulting array is fed into the shift register, comes back over here to the start, and it keeps on going. Trick is I need to initialize it with something. So I need to start it somewhere. Like in Python, we started with an empty array, right? Or an empty list. So on the outside of the shift register, on the input side, if you will, before the loop, I'm going to right click, create a constant. So start with a value of 0 in a 0 length array. It just initializes an empty array that I can fill. If I wanted to pull something out of the far end, I could put a wire here, and that would take whatever the final state of the array is once the loop is done. But I'm not going to worry about that for you. All right, so I got that, and this is going to be my y value. You see the y values in the bottom of this build xy graph thing. So I'm going to take all this, I'm going to drag it, whoopsie daisies. I'm going to drag it down underneath of that build xy graph thing because I want to keep my wires neat. All right, so and this is my y value. So I'm just going to grab another wire off that and shove it into there. You know, this little blue thing, I drag that away, it has this weird dashed line. That dashed line is what's called a cluster data type. This orange line we know is for a float or a double. When it's thin, it's a single value. When it's thick, it's an array. So we have an array going in, it becomes something called a dynamic data type. I think that's a cluster. So that's all that's going on there. You don't have to worry about it too much. Anyhow, that's our y values, but we need an x value too, right? So our x values, we want, if you saw me make the note on here, we want our x values to be time in seconds. So we need to keep track of how often we're running this. We also need to keep track, we also want to change how fast we're running it so that it doesn't go too fast. So if I go back into my programming palettes, click back into my block diagram, make sure to save by the way. One of the sub palettes is called timing. Once one to watch on it. I'm going to click into that. I'm going to grab this guy. It's called wait. And this guy, which is tick count. So tick count gives me says it gives me a millisecond timer value. Essentially, it tells me the present time relative to some reference in milliseconds, which is great. It's some way of keeping track of time. And if I put it outside of the loop, I know when I started, which is nice. I know relative to when my code is running. The wait thing, I can wire something to the left-hand side, tell it how many milliseconds I want this loop to just hold up for. Every time that that block is run, which is every time that the loop is run, it will pause for the number of milliseconds that I've told it to. So if I put a constant in here, I'll wait for 50 milliseconds, say. So every 50 milliseconds, this loop will run. Let's just make that 100 milliseconds. Or rather, every time the loop is run, it'll wait for 100 milliseconds. It'll do the rest of the loop really, 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 really fast. And then it'll wait for another 100 milliseconds. So it's my way of being able to, how do I say this? Being able to control how often this loop generates data. I can do the same thing if I wanted to collect data. If I wanted to collect it about once every 10th of a second, I could have the whole loop wait 100 milliseconds between times that it's run, between iterations. The output of the wait function, the wait block, is the present time. So if I want to figure out when how long it's been since the start of the code, well, all I have to do is to take the present time after I wait or whenever I run a loop and subtract that from my original time, right? So this clock out here runs once, right when the program starts before I enter the loop. And I go into the loop, wait for a little bit, and then how long it's been since that is just the subtraction of whatever the present millisecond timer value is minus what the initial millisecond timer value is. And every time that I run through the loop, I'll get a new value of how long it's been since the start of the loop. And I don't want to just multiply 100 milliseconds out by how many iterations I've been through, because it's not exact. It takes some time to do all of the other stuff in the loop. So I want to do something like this. Then I want to store that in an array so that I can graph it the same way that I did all of this stuff. So if I go into structures, or sorry, into array, I can pull out another build array block. See down here, I had my new value going into the bottom. So I'll have my new value going to the bottom here. Then I'll grab myself a shift register, wire those arrays together, and then wire that into the X input down here. Great. So I got my X and Y values, got all that stuff together. If I come over to here and hit run, you can see it's updating in real time. Problem is that number on the bottom, that doesn't look like seconds, like 6,000 seconds. That doesn't make sense. What's going on here? Well, if I go back here to my block diagram, you see that these are millisecond timer values. So my fault, that's in milliseconds right now. It's all these times are in milliseconds. So I'm going to get rid of that wire and convert from milliseconds into seconds, 1,000 milliseconds in a second. So just have to divide that by 1,000, can wire that all back together. It's not happy because there's some loose wires, so I'll just take Control B. Control B, remove broken wires. Should be all set. So if I run this again, there you go. Time's now in seconds. Life's great. All right. Now I just have to save it to a disk. Save it to the disk in form of a file. So whenever I hit this button, I want that to happen. But right now, if I hit this button, it stays clicked, right? It's like a light switch. It's on. Then when I hit again, it's off. I don't want that, right? I want it to be on, saved, and not be clicked anymore. Because also just continually try to save. It'll always be on. So if I right click on this button, hit properties, go over to operation, I can change how the button functions. Right now it's on switch. So it switches on, again, it switches off. If I hit latch, it'll go on, and as soon as LabVIEW reads it, it'll go back to what it was. So I can click it and it just keeps on going back. That's kind of what I want, right? When I click it, I want it to save and move on with life without trying to save twice until I tell it to. So I want latch until something. Latch until pressed is a nice one. So I'm just going to hit OK there. If I right click on the button, the mechanical action tab is the same set of things. So latch when pressed, that's what I want. All right, so when it's pressed, I want it to save. So if it's pressed, save. If not, don't save. So that kind of sounds like an if statement, right? Or a case structure. So I'm going to drag one of those suckers out in front here. Also should put comments here like get initial time. Oh, you probably noticed that I didn't initialize the array here and it still worked. It's a good idea to do it. Sometimes you can get away with it. Always do it. Always initialize your arrays. What's going on up there? There. There's that. It's a little bit bigger. You might find yourself changing the size of your loops a whole lot, just so that things look pretty and aren't confusing. All right, so I have this button, I have my case structure. Let's get to it. So I'm going to wire my button to the selector on my case structure. Then I'm going to start my file. So in Python, what we had to do is we had to make a file, write data to the file, and then close the file. Those are the three things we had to do in order to write things to a file from Python. It's similar in LabVIEW. So I'm going to go back up to my programming palette. One of these is the file IO subpalette. I'm going to use the open create replace file block, drag that puppy in there. This is a ton of different inputs here. So let's have a look at what's going on. Not all of them that we need. We don't need all of them. So top one here, file path, use dialog. What's in parentheses is what it's going to do by default. And that sounds great. Using dialog is like when we're in Word, we want to open a file. We hit Control O or file open, and it brings up a dialog box. You search around for where you want your file to go. That sounds great. Let's leave that one alone. Next one down, operation, open. So it's always going to try to open a file. We don't want to do that. We want to create a new file or replace ones that's there. So I'm going to right click, create constant, get some room there, and then select replace or create. That's what I want. That's what I want to see happen with this. Also, it's expanding in a bit here. So you see wires getting covered up. Right click, clean up wire, make it easy to read. All right. So we're creating and replacing a file. Next, port down, access, read, write. Perfect. I want to write things. That's one of the options. Great. Okay, error in, don't care about. Buffering, don't care about. Error out, don't care about. Cancel, don't care about. Prompt, I don't care about. I mean, I could, but I don't really care. I'm not going to make some sort of fancy user prompt right now. Refnum out. Once the file is created, it's going to produce a refnum. And that refnum is going to be the file, really. And if I want that file to be accessed, I always have to pass that refnum along to the block that's going to do it. So for example, if I pull in a format into file block, this is how I write to a file. One of the inputs to this block, if I look here, is an input file. That input file is the refnum. So I wire those two together. Great. So while I have this block here, I might as well write some things. So like if I'm writing data to a file, I should have some headers that say what that data is, right? So like here I have time and dial value, right? So let's write those into the file. Down here I have input 1. You see it's orange, so that means it's a number. That's really just by default. I can make it whatever I want. So I'm going to go up to my programming palette, go to my strings subpalette. grab a string constant. I'm going to say what my first thing is. It would be make it time in seconds. Well, I'll get a second string constant on here. That'd be my dial value. I'm going to wire time up to that input, and you see it automatically changes data type. It's now pink. Pink is the color of a string. So, but I only have one input, right? That kind of sucks. Well, I hover over that block. I have these blue blocks again. I can drag one down. I have the second input. Heck, I can get as many inputs as I want. Only need two, and I'll wire dial value to my second one. Just clean up wires so it looks nice. Great. All right, now I have to tell it how to put it in. If you remember from Python, we had a format statement, right? We had when you wanted to put a number or a variable into a string, you had to use a format statement. You had what's called a curly bracket. It was a curly bracket, colon, period, 3F if you wanted to put a number with 3 decimal places into that string, right? You have to do the same thing here. So where it says format string up top, I'm going to right click on that, create constant. Here I have 2 strings to put in. So I'm going to hit %s. \t is a tab, another %s, and \n takes me to a new line. So it puts in a string, tabs over, puts in a new string, goes to a new line so that I can put more data in, put all my data in. Great. So that should get me the first thing. And if I want to test that, I can go over to my File IO tab, grab my close file, wire the ref num there to the ref num there, run, make some data, click save to disk. Ask me to save to disk. I'm going to go over, I'm going to save it in test.txt. Make sure you add the .txt or your computer won't know what to do with it. I'll save that, stop, go over, open that up. And there's what I just had the program save. Time, and it tabbed over, wrote the word dial value, and went to a new line. Great. So now I just have to add data. I'm going to get rid of this wire for a second. So I'm about to put something in the middle. So when we did this in Python, we used a for loop, right? And you used the for loop to go through each element in an array, and we wrote it to a file. So let's do the same thing. Grab a for loop, drag it out right in the middle there between the time we wrote the headers in and closed the file. Said we're right into a file, so I have to get a format into file block going. And probably need 2 inputs again, one for time, one for the dial value. And if we were doing this in Python, we'd have to go one value at a time. So like for I in range blah, array square bracket I, so on and so forth, to get every element of the array. Nice thing about LabVIEW, we don't have to worry about that. So I think my first column is time, so I can just grab that array, wire it into the front one, and you see, so you have a solid block here. That's called a tunnel. It shows where data is entering the case structure. And you have this tunnel here, but it's different. You have 2 square brackets in it. So it's called an auto-indexed tunnel. So what that does is on each iteration of the for loop, it goes through your array one element at a time. The same that we did in Python by doing the square bracket I stuff, except it does it for you. So great. It's doing everything that we want. Looks like it moved my wires around a little bit here, but that's okay. I'm still, if I follow the wires, it still grabs my time array. That's all I'm looking for. Also gonna have to grab my dial value array. So I'll do that, wire it up to my second one. Then I have 2 numbers, and I want to write these to 3 decimal places. So I'll write out the print format specifier %.3f tab %.3f new line. Shove that over there. On either grab my ref num. Great, that looks good. Output that to my close file. Oh, that doesn't look good. It's not happy. But why is it not happy? Well, if I look at the tunnel it's using an auto-index tunnel, but I'm not putting an array into the auto-index tunnel. So it's going, I want to index this. I want to grab every single one of these, but I don't know, there's no array. So it's kind of flipping out. We can change that though. We can change it to be a regular tunnel, like these blocks up here where they just give me a value. So if I right click on it, tunnel mode, last value, life's great. All right, so we're almost there. Only thing you need to change is don't know how many times to run this loop. Well, it probably should be as many times as we have data for, right? So conveniently, this little guy down over here, that tracks how many times the while loops run. That should equal the total number of bits of data that I have. So I can wire that guy up to there. We should be good. So let's give this a shot. So run this, make some data, click save to disk, save this test.txt, stop that, pull this up, look at all that data. And look at the time, they're separated almost perfectly by 1/10 of a second each. You see, it's not quite perfect. It's maybe a few 10,000ths of a second difference in how fast the loop is running versus how fast we would like it to run, but it ain't bad. It ain't bad. Less than maybe a little less than 1% off. So, all right. Just add some comments here. And we should be good to go. Make sure to save often, and that's what we did in class this week.